Chapter 2 is going to be an intensive study of functions, which we've done in Algebra 1 and in Algebra 2. We're going to take all these things that we've learned, do a little bit more with it. So what was a function? Well, the pre-calculus version of a function is f is a rule that assigns to each element x in a set A exactly one element called f of x in a set B. That's just a fancy way of saying that it takes each domain and pairs it with exactly one range value. Or we can try that again. It takes exactly one input and pairs it with exactly one output. Or the number that gets plugged into the function can also be known as the independent variable. And the number that comes out of the function is known as the dependent variable. All these things mean exactly the same thing. In essence, a function is what you get when you pair exactly one domain value, one x coordinate, with exactly one range y coordinate. So let's do an example where we're working with a function. A function is defined by the formula f of x is equal to x squared plus 4. Express in words how f acts on the input x to produce the output f of x. All they're asking you to say is that you square x, then add 4. All you have to do is think about this in terms of order of operations. If you were to plug a number into this equation, what would you do to simplify it if you did not have a calculator? Now let's evaluate the function for some specific x values. This is called function notation, and it's just a fancy way of saying that we're going to substitute a number into an equation for x. So I want to find f of 3. Well, all that says is square 3 and add 4. 9 plus 4 is 13. F of negative 2 says square negative 2 and then add 4. Well, negative 2 squared is 4, plus 4 is 8. Square the square root of 5 and then add 4. Remember that a square and a square root cancel each other. So the square root squared is going to be just the number under the radical. So it's just 5 plus 4 is 9. Let's find the domain and range of f of x equals x squared plus 4. Well, when finding the domain and range, you can look at it in a couple different ways. One way is to look at it by graphing it. If you graph it in your calculator, it's going to look something like this. The domain says, what numbers can you plug in place of x and always get a number out? Well, every number in the world can you plug in for x, square it, and then add 4. You'll always get a number out. We say that the domain is every number in the set of real numbers. This fancy looking R with an extra leg on the side is the mathematical symbol, I guess you could say, for all real numbers. How about the range? What kind of numbers come out of this function when we evaluate it? Well, I want you to look at the graph, or another way of looking at this is look at the table of values. You know, when we plugged in negative 3, 13 came out. If you plugged in negative 2, you got 8. If you plugged in negative 1, you'd get 5. 0, 4. And if you plug in positive 1, you'd get 5. If you plugged in positive 2, you'd get 8. And you notice that the y values start repeating themselves. Well, I want you to notice that the smallest y value is 4. And all the rest of the y values that come out of the function are all bigger than that. So we say that the range is the y values are greater than or equal to 4. Another way of writing that is to close the use the bracket, and that says it starts at 4 and it goes off to infinity in the positive direction. That's our set notation of y greater than or equal to 4. Let's do this again. Let f of x equal 3x squared plus x minus 5. Evaluate each function. So when you plug in -2, remember order of operations. And here's another hint. Whenever you plug a number into an expression, put it in parentheses, particularly if you're going to put it in your calculator, because sometimes the calculator doesn't like it if you don't put parentheses. Well, I'm going to do this the long way because I don't have a calculator in my hand. In order to evaluate this, first I'm going to square the -2. Then I'm going to multiply, and then I'm going to add and subtract from left to right. And I find out the answer is 5. F of 0. Oops. That's just going to be 0 plus 0 minus 5, so I get -5. I've done that one, I've done that one. F of 4, 3 times 4 squared plus 4 minus 5. Square first, then multiply, then add and subtract from left to right. 48 plus 4 is 52. 52 minus 5 is 47. Now we need to do f of 1/2. I'm going to go to the next page to do that. First, I'm going to square the 1/2. That's 1/4. Then I'm going to multiply. And then, because I don't have a calculator, I'm going to do this by getting a common denominator by writing equivalent fractions. 1/2 is the same as 2/4. 5 is the same as 20/4. And now I can just combine the numerators. So 3 plus 2 is 5, minus 20 is -15/4. Here's a practical application of a function, plugging number into a function. A cell phone plan costs $39 a month. The plan includes 400 free minutes and charges 20 cents for each additional minute of usage. The monthly charges are given by a function, the monthly charges are a function of the number of minutes used, given by this piecewise function. C of x is equal to 39 if x is anywhere between 0 and 400. And C of x is equal to 39 plus 0.20, x minus 400 if x is greater than 400. Find C of 100, C of 400, and C of 480. Well, this is just a matter of figuring out where you're going to plug numbers into a function. C of 100 is going to get plugged into the first function, which is just 39, because 100 is between 0 and 400 minutes. How about C of 400? Which one does that get plugged into? Well, it gets plugged into the first one, so the answer is again 39. It's only when x is greater than 400 do we plug into the second one. Well, C of 480 says that's more than 400. So to plug that in, you're going to do 39 plus 0.20, 480 minus 400. So that's going to multiply 80 times 0.20 and then add 39. And you're going to get 55. Let's look at another function that's going to kind of push us in the direction of something called a limit. I want to use the function f of x is equal to 2x squared plus 3x minus 1, and I want to evaluate f of a plus h, and f of a plus h minus f of a all over h. Well, f of a is easy. That's just going to be 2a squared plus 3a minus 1. And f of a plus h, also not that bad. Hopefully you're now at the point where you can square the a plus h without doing a lot of work. You should get 2a squared plus 2ah plus h squared. And then I'll distribute. And then I got to do a little more distributing. 2a squared plus 4ah plus h squared plus 3a plus 3h minus 1. And I'm done because there are no like terms to combine. So to do the last part, I've already found f of a plus h and f of a. So I'm ready to just subtract them. I'm going to take the first value is f of a plus h, and I'm going to subtract the 2a squared, subtract the 3a, but add the 1, and then I'll divide that all by h. Now what you're going to notice is you've got some like terms that go away. So you end up left with 4ah plus h squared plus 3h all over h. That's 4a plus h plus 3.